Good morning. We will get started here in just a second for the Lighting and Retrofits and Audits webinar.
Morning, folks.
Here come some more people here right at 10 o'clock. Give it just another 30 seconds or so and we'll let Eric go.
Great.
All right, it's a minute after 10 o'clock, so let's get going. You have found yourselves in the webinar, Lighting, Retrofits, and Audit. And Eric up there, wave Eric, is going to be your presenter, but this disembodied voice is going to talk to you for just a minute. I'm Katie. I work with Eric at the Lighting Design Lab. And you want to advance the slide, Eric, because I don't have any control.
All right, let's see if we can do this. Stand by. Well, there we go. Sorry about that. Try it again. There we go.
It worked. And just in case you haven't attended a webinar with us before, you will be on mute, but over in the control bar on the side of your screen, there's a chat function and you can type questions to us at any time, and we will pause every few minutes, 12 minutes or so, it says, to answer those questions. And Eric has, I think, 6 different polls you'll get to participate in. We love the participation. But then following the webinar, there's a really short survey, takes a minute, if that. And if you are an AIA member and you would like your 2 learning units, make sure you go through that survey and put your AIA number in there. This webinar is recorded, and we'll put the recording and the slide deck that Eric's going through up on our website within about a week of today. And there is our general email if you find yourself with questions after the webinar or anytime. And then just a little bit about Lighting Design Lab. We are powered by Seattle City Light. We're actually all Seattle City Light employees and have been for decades.
Yes.
And Lighting Design Lab works with all members of the lighting and broader electrification community, end-use customers, trade allies, design allies. Eric was really channeling the Olympics here just to be relevant, and it does take a village. And you're part of the first rectangle there with education and training right now, but we also do technology evaluation. We've got lots of great tools and resources, you know, physical light meters, that kind of thing, and on our website. And do our part to aggregate information for you. If you can't make it to, you know, the big conferences, we will come back and have articles or, you know, a condensed webinar with that information for you. We try to get everything out to you.
All right, thanks, Katie. Well, I think we'll get started on the class. And I want to welcome you all. You know, I really like this slide, particularly this picture, because it kind of drives home that you need to be sure that your goals are the same as your customers' goals. If there's any question about what you're seeing here, this was a little restaurant, and they had taken one of the lights and used it to power the radio. So kind of can see where their priorities lie. It doesn't mean that we can't, in a good retrofit, solve both of these problems. Maybe there's a way they can get lighting and music. But the upshot is, it doesn't hurt to find out some of these things. So just a little bit about me. I've been at the lab since 1995. Seen a lot of things come and go. I remember when halogen was going to save the world, and yeah, right now it looks like LEDs are all the rage, and so we're excited for that. Yeah, if you want to know more about me or anything like that, you can always reach out. I'd be happy to discuss any questions you might have about lighting, because I've done it all from roadway to warehouse to classrooms to offices and everything, and residential. So, all right. So today we're going to look at just do a little overview of some procedures and issues around doing a lighting audit, look at some common retrofit strategies, and then we'll look at also going to touch on controls, and in particular some of the advantages of luminaire level lighting controls. I also like this particular picture because it really sort of drives home the fact that, you never know what you're going to find. You may have good as-built drawings for your customer, but you really kind of need to actually send somebody out who's got a little bit of lighting knowledge to see what's really there, because people find all kinds of amazing ways to do workarounds on lighting. In this case, this was a troffer type fixture that was sort of suspended, fluorescent, and the customer decided to convert it into a track fixture that's probably incandescent. So they went from maybe 2 30-watt lamps to possibly 3 75-watt lamps. They went from a general lighting fixture to something that's more focused, although in reality they were using it focused lighting as a general lighting. It's kind of crazy. Anyway, I love the picture. It's just nuts. All right, so here's a little quiz to find out a little bit more about what our audience is and what you're interested in. Katie?
Yep, so I have launched the poll. Eric, can you see the poll or just the screen that you have?
I can't see it.
Well, it's collecting responses.
Yes.
I'll close it in just a second, and then we should be able to see the result. Still voting, still voting. I'm gonna give it 10 more seconds.
Okay. Yeah, we're just trying to gauge, how much, what kind of knowledge you have, or what your hope is for this class.
Okay, I'm gonna close it here and share it, and we'll see it. Can you see the sharing, Eric?
No.
Oh man. Okay, so just so you can know, most of the people have done lots of audits and retrofits, but there's 38% that are new to the field and want to know about every aspect. Now, 8% thought this was a cooking class, so I'm really interested to see the survey at the end. All right. Great. I'm going to hide this, and it'll go back to your screen.
There
you go.
All right, thanks. Right. So, yeah, I mean, so some of you, who've done audits, that's great. Hopefully there'll be something new for you. And those of you who are new to the field, hopefully there'll be some good information here. One of the things I've learned over the years, and even that first little slide touched on it, is you really want to determine the goals and motivation of the client. And a lot of times we see people say, we want to save energy, but what they really want to do is save money. And that's perfectly legitimate. That's nothing to be ashamed of. In fact, they should be proud of the fact that they want to save on their operating costs. It's just basic business sense to not spend more than you need to. So saving money is fine if they want to say that. That should be, if that's their priority, then you just need to know that. The reason I kind of stress that a little bit is because I could walk into almost any room, any type of building, and save energy. But it may cost money to do that, and it may not be something that's going to save a lot of the maximize their dollar savings. But some clients, their priority is energy savings for whatever reason, either for their public image, or maybe they they just have a desire to be as green as possible, save as much energy as possible. Maybe they're going for LEED Platinum. Who knows what the motivation is? Energy saving is their priority. And so you can't assume that the thing that saves the most energy or that saves the most money is their priority. And I've seen that happen a lot, where contractors are like, oh yeah, we could do it this way, but it's going to take 7 years to pay back instead of 3 years. That may be fine for some customers. You just need to have that conversation just so everybody's clear about the outcomes and what the goals are. And then these other ones, it could be that they want to have a productivity enhancement. The lighting is getting in the way of maximizing their productivity, but they also want to avoid perhaps disruptions in the retrofit process. It could be that the lighting is bad, okay, and you kind of need to. They might say, "Oh, we have terrible lighting." You kind of need to press on that a little bit too, and say, "Well, is it you just don't have enough lighting, or is there something about the lighting that's poor quality?" As an example, I love this picture on the upper right there. That's actually a hotel lobby, and any of you who've been around lighting a while know that if I say that this lobby was lit with high pressure sodium recessed cans, your head's going to explode. So high pressure sodium was lighting that was used historically with street lighting, or maybe parking lot lighting, or things like that. It's pretty poor quality. The only reason that this even looks like anything in this picture is because it's during the day, and there's a big daylit atrium that's slightly off camera that you can't see, so it's letting some daylight in. But at night, it must be like the Attack of the Zombies. Anyway, so you just never know what you'll find out there. So this would be a case of bad quality lighting. It could also be that there's a timing issue. The lighting system is failing. It's old, it's aging out, and they just need to replace it. And so it's time to, but maybe they're not doing any other kind of remodel. So it's really just a lighting retrofit. So that's what's motivating it, is it's just failing. It could also be that they are doing a building remodel, and because of that, their code has triggered that they have to change the lighting. Maybe their power density is too high, or some other thing. And honestly, it could be all of those. It could be that you're going to save them money, you're going to save them energy, they're going to get higher productivity, they're going to get better quality lighting, they're going to get a new system, and it's going to conform to code. Ideally, every project should have some aspect of that. It's just really, you just need to look at their priorities. And related to that is, especially on a big project, maybe you're doing a campus, or you're doing a large office building, there's going to be different constituencies involved, and they may all have different priorities as well, or at least different emphasis on what they would like, or how they'd like to see it go. The owner maybe wants low long-term costs. The tenant, maybe they're moving in and they want to say that their workspace is very green. You might have engineers involved that want to maximize the energy efficiency. You might have a contractor who's concerned about first costs and low bids. Again, nothing wrong with that. You just need to know how that's going. You might have a facility operator that wants low maintenance. There could be great lighting, but they're like, I can't maintain this, or they think they can. You might have users and they really just want good lighting quality. They don't care about some of this other stuff. They just want to be able to see well and perform their jobs. And then there's the architect. Maybe they're concerned about how the lighting looks and how the fixtures look, some of these other things, and maybe they don't know much about lighting, but they know about visual appearance. And again, so hopefully everybody gets what they want, but it is important to be aware that there's going to be a little push and pull during the process. All right, so you're called in. You always want to do a preliminary survey, and I found a lot of times that the thing we hear about is the hardest thing. The client calls and they're like, yeah, we've got this X type of fixture or this type of space, and how do we want to do a retrofit for this building, but how do we do it? And you can spend a lot of time and effort on maybe one or two trouble spots and not realize that the whole building is actually fairly easy, or maybe it's going to be good outcomes, and you just have this one hard area. And this often leads to a discussion where I'll say, well, do you really need to retrofit the entire building? And sometimes they're like, yeah, we've been given direction that everything's got to be changed to LED. And I worked on a project where that was going to be pretty simple for 95% of it, and they had some bollards in this case, exterior lighting bollards, that there was just going to be no decent retrofit for those. So they either had to put in new fixtures, which is kind of pricey, or they just had to say that and they were fairly new. They were probably put in the last 10 years and they were functioning, but they were just metal halide. So that's a discussion you have to have. It's like, okay, we doing these, or can we just take a pass on those? And this is where sometimes a detailed audit is warranted, just to know, be sure you know what's happening. And then you always again want to come back to that question: how do you like the existing lighting? And again, that could be, the term like can have different shades of meaning. The lighting quality could be fine. It's just they're pulling their hair out trying to maintain it. Or it may be that it's sort of limping along. It's just bad lighting, and they just want it. Nobody really likes it. It's not bright enough, or it's poor quality. So good to have that discussion with them. So is this building a good candidate for a retrofit? That's a question. So the client wants to do a retrofit, and you need to calibrate their expectations a little bit on how much energy they'll save or how easy it's going to be. So some clues that you might look at for particularly cost effectiveness is hours of operation, right? Is this a 24-hour facility, or is it 8 hours a day? Or sometimes it's a lot less than that. We get calls from churches is a good example, where they have their sanctuary, and it's all incandescent, let's say, and it's was put in 40, 50 years ago, and they've got it's going to be a real challenge to retrofit it. It's using a lot of energy, but guess what? It's not really on very much. It's only maybe 2-3 times a week for a few hours at a time. So that's going to be a different discussion than, say, a facility like we're looking at here. This what looks like a computer server lab area. That might be 24 hours a day, fairly brightly lit. Then the age of the system is going to give you an indication as to the viability of the retrofit. Another thing is, does the utility have some sort of demand timing element where, if they are using a certain amount of energy at a certain time, the rates will go up, or maybe the rates are generally high. If you're in Hawaii or the East Coast, it's a lot easier to do retrofits than parts of, Southern Idaho, or, even in Washington State, where we have very low rates. So the utilities offering rebates, that's one thing you want to look at. They may or may not. Facilities, higher light levels than required, right? So, the eye is very adaptive. I could walk into this space that we're seeing here and say, yeah, it's bright, but whatever. But it might be 120 foot candles. You can go out on a beach and it could be 1,200 foot candles, or even 10,000 foot candles. You can adapt. So it's maybe say it's over 100 foot candles. That's not a problem. It might seem bright, but you could cut that in half and it would still seem bright. So you want to look at the light levels, and we'll talk a little bit about that later. The presence of non-dimmed incandescent lamps, we're seeing less and less of that. Although a colleague of mine recently went into a restaurant in Seattle, and the whole back of the house was lit with T12 fluorescence, and anybody who's been in lighting for any length of time knows that T12 is, beyond being a fluorescent, it's an old style fluorescent. It's not even modern fluorescent. So yeah, that's a lot of energy potential savings there. And you want to look at other energy saving opportunities, right? So one is underutilized daylighting. I've walked into places where they had skylights that were painted over. It may be that because there was problems with the daylighting and the skylights, and that's a different conversation. But it could be a way to get some good lighting in there for a large portion of the day. And related to that, they may not have any kind of control. So like this server room as an example, it may be that people go in there, infrequently. This looks busy, there's 3 people in there, but it could be that, all night long, someone goes in there once an hour and looks at something and leaves and goes to another part of the building. We just don't know. So controls could be brought to bear. Another question that doesn't hurt to ask is how much the client is actually paying for the lighting. They may not really know that. They just pay their electric bill, and it could be, for certain kinds of commercial spaces, the electric the lighting portion of their electric bill might be very small, but for other types of things like so they might have industrial processes that use electricity, and so that's the lighting is a fraction. But for other things like, say, a warehouse or office spaces, the lighting could be a pretty large portion of their consumption. So, buildings that maybe are not as cost effective, facility has short hours of operation. We discussed that with, say, a church, but that could be true with just a regular office. Maybe they just keep, 9 to 5 hours, and, maybe after 6 o'clock, everybody's gone and it's dark all night. So it's a little different calculation than, say, a Target or a retail store of some kind where they have 14 hours a day, 6 days a week. Facility exceeds existing efficiency requirements, so maybe it's a relatively new building, and they've already, they're meeting codes. There might not be a lot of savings potential. Facility pays little for energy and has no peak demand, so they're in low rates, so energy rates, so it's going to be a little harder. Or a facility's undergone a recent retrofit. We've seen that where they want to go switch to all LED, but the lighting is relatively new, and so there's not going to be as much savings as it would be for an older building with older lighting. I like this picture. Maybe is it already a green building? Okay, so gotta find those things out. So here's a little question. which is more likely to be cost effective? And we'll just talk through this one. I don't think we have a quiz for this one, but it's so which is more likely to be cost effective, a community center gymnasium or a pro sports stadium? So we look at this in the right-hand side here, and we've got an arena here with, these are dozens and dozens of 1,000-watt metal halide lamps, and that's a really big load. And then we've got this community center, and they've got maybe 2 dozen high bay type lights, and maybe they're 250 watts each. But guess what? The community center is lit all day long, and they don't have much daylight in there. So if they're using those lights all day and most of into the evening, whereas that stadium, maybe it's like where the what are they calling it now? It's on CenturyLink. Maybe it is CenturyLink. Anyway, where the Seahawks play.
Lumen Field.
There we go. Thank you.
Yes, Lumen.
Okay, right. So they're not playing that much, and there's the odd concert or some sort of other event there, but it's dark a lot of the time. So it's a different calculation. Again, here we've got in the lower section on the left, we've got a office building lobby, nice and brightly lit, and then we have a hotel lobby. Same deal, with the office, people go home at night, and maybe just a few lights are left on. Whereas with the hotel, that's 24/7, 365 days a year. That's the lighting, and so that's even though maybe the loads might be lower, the hours of operation are much greater. Okay, so if warranted, a detailed audit may be in order. And we'll touch on that a little bit later, but, you want to do a plan survey. You want to try and find plans if you can. You want to find out if they're as-built. We've seen a big difference between, the drawings that the architect generates and then what actually gets built, even in terms of room dimensions. And over the years, sometimes spaces get divided up differently. And the lighting maybe the lighting doesn't change, but the lighting use changes. So that's something to be aware of. So anyway, you want to identify spaces that are going to be similar, so you don't have to, maybe you don't need to audit every space, but you need to look at a few of them. Look at the electrical circuiting, see how you can break things up for controls. You want to check current recommended light levels and lighting guides. So, down at the bottom there, we have IS recommendations, and those are certainly the foundation of where lighting levels would be. That said, we sometimes see building standards, so maybe the IS recommends 60-foot candles for a space, but you've got a client, maybe they're a retailer, and they say, no, we need 80-foot candles in our aisles, or at our end aisles, or whatever, however they have it. There may be some reason that they want higher light levels. Or you may have, like in Washington State, we have the WAC, the Washington Administrative Code, and maybe the IS recommends a certain light level in classrooms, and the WAC requires something different, usually maybe a little higher. But you need to check those things. So you want to be able to document the existing conditions. So that would be some tools. You don't want to just show up, with nothing but your good intentions, although that's always a good start. But you want a light meter. I don't live and die by light meters, but it does help you to have a basis. You can walk into one space and you'll get a certain light level. You walk down the hallway into a similar space and your eye might think it's the same, but it could be half the light, or easily a third of the light, and you wouldn't know the difference. Or it could be 30% brighter and you wouldn't really be able to tell. So a light meter will tell you if there's consistent lighting, if that's what they want, maybe classroom to classroom, office to office. It doesn't hurt to have a way to measure spaces. We can count ceiling tiles, but that's not always possible. Ceiling tiles are usually 2 foot by 4 feet, and so that's a way to get a quick, measurement, fast and dirty. But maybe you need something more precise. Tape measures, laser pointers, or laser measures rather, are good. Although I had a case where I was doing some exterior measuring outside, and a laser usually isn't good during the day, especially if you're in bright light conditions. You can't see that little red dot 200 feet away. So you may want something else, or you have to go back at night, or who knows what. So a notebook, tablet, way to record what you're doing. A tape recorder, sometimes people do that. They'll walk through a space, especially if they're sort of by themselves doing the audit, or maybe with a colleague, and they're just talking into the recorder about what they're seeing. You want a camera with a zoom. But guess what? We'll touch on this a little later, but everybody is like, oh, I got my phone with me. It's got a camera on it. But having an actual camera with maybe a zoom on it is going to be important. Let's see here. So, this has a decent little lens, and it can go up to 12x, and we'll see why you might want that. Binoculars for a similar reason, or a monocular. You don't need a full-on binocular, but it's helpful, as we'll see in a minute. Then you want some various PPE, personal protective gear, earplugs. A colleague of mine was saying that, he once, probably not so much anymore, but he went to an industrial facility where they required ear protection, and a guy handed him a pair of earplugs, and they were not, they were used. They weren't new ones. So he was like, so he carries them with his own now. And I recommend you do that too. And some hard hats, you want to have that in the car and to find out if you're going to need it. Sometimes they'll provide their own goggles with safety vest. A little counter, sometimes it's quick. If you're going from space to space, you can use a little mechanical counter. And then it doesn't hurt to have, maybe if you're working with a certain utility, to have some of those utility forms, you can fill them out on the spot. So you're doing an audit, you want to document the lighting systems, you want to look at light levels, you want to look at the luminaire types, how many there are, what mounting. Sometimes we've seen where, it looks like there's all these different kinds of fixtures, but it turns out it's the same fixture. Sometimes they're surface mounted, sometimes they're hung on chain, sometimes they're recessed into the ceiling, but it's really all the same fixture. You want to know about the type of lamps they've got, the wattage, the color, make some note about the color. You don't necessarily have to be all that precise, but you want to see if there's color consistency from room to room or even fixture to fixture. The ballast types and the voltage, since most retrofits are going to be dealing with either metal high pressure, high intensity discharge, or fluorescent of some kind. And those will generally have ballasts. You want to look at what the daylighting conditions are and what the daylighting possibilities are. So they may have poor daylighting conditions, but good possibilities, or they may have great daylighting, and you want to make a note of that too. Have the luminaires been retrofitted or modified? Because that'll have a big impact on the as-builts. And so you would need to know that. What controls are in place and are they working, and room reflectances. And we'll touch on that to some extent as we go. So you also want to look at the conditions, of the general building. What is the condition of the lighting? Is it all broken down, worn out lighting? In which case, you may do a retrofit, but you're not going to retrofit those fixtures. You're going to get rid of those fixtures because they're shot. And so the client may want to save them, and you need to have a discussion with them. Are there any controls in use? And if so, are they, like I said, are they working? Are the fixtures on when they should be off, maybe, in your opinion? Maybe they don't know. The other conditions about the building, what's the ceiling type? Is there access to the plenum where the wiring and the fixtures might be? It may be that there's asbestos up there and there's really sort of no actual access. It may be that it's just very dirty. And so if you're going to be up in that plenum, there's going to be a significant disruption in terms of cleaning and a follow through. Again, daylighting opportunities, reflectance of interior surfaces, and also what's in that maintenance closet. Doesn't hurt to look and see if they have spare lamps, what those are, spare ballasts, things like that, that can save you some ladder work. If it looks like they have a very clean, well-organized maintenance closet, that might tell you a lot. If it's all haphazard, you probably have to go look at the fixtures closer. Okay, it looks like we have a quiz here.
All right, I will open this first pop quiz, and there may be more than one correct answer, so choose all that apply. And while this is going, I just wanted to tell you, Eric, that Bruce wrote in and said that he once was at a large government office, and the office occupants had painted several tubes black because they didn't have any dimming controls and weren't allowed to remove the lights. Yeah.
Okay, good to know. I've seen some pretty crazy stuff. I hadn't seen the paint on the lamp itself. That's a first. Good. Thank you for sharing.
All right, another 5 seconds or so for the poll here. 3, 2, 1. Get your vote in. Closed. Okay, so let's share the results here. And 95% said the facility has long hours of operation.
Okay.
And then 84% hospital parking garage with 30-year-old lights. 68% measured light levels are higher than recommended practice. And just over half chose both the community theater stage has 50 or more 500-watt lights, and the customer's going for LEED certification.
Okay. Yeah. Well, that's good. So yeah, all of those were probably right, except that middle one, the community theater. Yeah, you have to look at how often they have events there. So, they may be doing theater, and then they might also be doing the public events there that are not related to the theater. Maybe they have concerts and lots going on. That would be a discussion. But if they're just doing, 8 shows a year for a week at a time, that stage is dark most of the time. So it would be a stretch to see that pay it for itself. Now, maybe that they just want to do it anyway, and that's admirable. Maybe they got a big grant to do it. All right. So document existing light levels. And, there's going to be not one right answer necessarily for what the proper light levels are, but what is the proposed light level? What does the client want? And what is that based on, right? So they might be saying, oh, well, we need 100-foot candles just because someone told them that was a big number and they want it nice and bright. Or maybe they're going on some documentation. Where is it? Oh, somewhere. I've got a copy of the IS handbook right here. But guess what? This is volume 1, first edition. So if I'm making my light level recommendations based on that authoritative document, those light levels are going to be way high. Over the years, the light levels have been found to be able to go lower. And to be actually often improving visibility in some cases. And sometimes they've got building documentation, and if you look at it, it was written in the 70s, so you want to see, is it up to date? Then what's recommended, and again, that could be what's proposed, what's recommended, similar kind of thing. Are the light levels consistent throughout the space? And are all the users happy with the light levels? Now, you can get into a real mess if you start polling everybody. Light levels, there's about paint? You know, what color should we paint this wall? Everyone's going to have an opinion. So maybe you want to find out in general how people feel about it, or you want to ask some key decision makers. But anyway, so it doesn't hurt to ask some of those things. Right. Then you want to document existing luminaires, the existing lighting fixtures. And here's a case where we're talking about as-built and retrofits, and so you look at a fixture and you see there's a label on that fixture. If I look at the drawing that's on the upper left, I see a label there, and I'm like, oh, look at that. So I take out my iPhone. It's got a pretty good camera. I zoom in. Yeah, look at that label. But when I try to expand that picture, I don't get any usable information. Whereas if I took an actual camera with a good optic and a zoom, if you look at the right side, there's that label again, and I can put that on my computer and zoom in. I can find out all kinds of information about that fixture, and I can read the label. Now I could get a ladder out and do the same thing, or I could ask the customer, what's the wattage of that lamp? But I've been in situations where they're like, oh, those are 400 watt lamps, and it turns out they're 250s. They just don't know. I mean, they should know, but they sometimes don't. Here's another case where there was a canopy. And again, the client was sure they had 150 watt metal halides. And so, I didn't make a big deal out of it, but actually they thought they were 100 watt. I took out my camera and we kind of zoomed in, and I was able to just there on the back of the camera to zoom in on the picture, and I said, well, it looks like they're 70s. He said, oh, okay. It wasn't a big deal. I didn't say you're wrong. How stupid could you be? But we just sort of like, okay. So, that tells them going forward, okay, so we've got 100, we thought we had 100 watt lamps, but they're 70s. That's going to change their calculation as far as energy savings and dollar savings, and certainly the utility is going to want information. So it saves time if you have a good camera with you. And then you want to document the type of the light distribution from the luminaires. And we're not going to get into a real long discussion about this, but some types of fixtures are called direct luminaires, and all the light comes out one direction, usually down. If that's what the client has and they want to go to something different, we'll see that might be an issue. But so you want to, in each space you're going, you want to document what the fixture is, what the wattage is, and what the type of distribution is. Here's a case where we have indirect luminaires, right? So they've got, if you look at the upper right-hand corner, you can see all the lights coming up, usually with an indirect luminaire. The one in the lower right, that's a wall-mounted fixture. All the light goes up. They need to bounce off of a reflective surface. So if part of this retrofit is a remodel and the client's planning to say, take out all the ceiling tiles and spray paint the ceiling black, then they need to change the distribution of the fixtures, because that would just be a discussion. It gets to be kind of a design issue, but you need to at least let them know, and we'll talk about that a little bit later. You can see in the lower right-hand corner, those are indirect fixtures. And so if they're going to paint that ceiling a different color, just like the fixture in the middle, that linear pendant, it's got a little bit of light that comes down, but most of the light is going up. So just because there's a little light coming down, you need to look at where most of that light's coming from. And then, indirect, direct, or direct, indirect, there's different shades of that, but some of the light goes up, some goes down. And kind of as I suggested earlier, like that bowl fixture that's in the middle, lower middle, it radiates some light out. It gives a glowy appearance, but probably over 70% of the light from a fixture like that comes out the top. So it's, largely indirect. Just like that a high bay fixture that's in the middle of the page with that glass prism, if it's a well-designed high bay fixture with a prism like that, it's sending most of the light down. It provides a little bit of a glow. You might get 20% hitting the ceiling, coming out through the glass, but mostly it's designed to direct that light down. So here's a case where we've got this, restaurant, let's say, and they decide they don't like those schoolhouse type fixtures that they've got, those little glowing pendants, or they're changing them and they want to change them to something more modern. So they see this cool metal cylinder. Let's say that's the one they picked in the lower left corner. And that's fine. You need to let them know, though, that the ceiling's going to be dark if they use that fixture. They might say, great, because we hate that ceiling. Or they might say, oh, no, we can't have that. We love the wood ceiling. You just have to ask them. And because that little metal cylinder is going to direct all the light down. And again, that's perfectly legitimate if that's what they're interested in. So you want to audit the fixtures. What's the condition of the components? And this, it's probably not practical to look at every fixture, but you might look at a few just to get a sense of the general condition. Open up one or two. I can see in this fixture, we've got, if you look at the sockets, the tombstones on there, they look like they're kind of fried. So I can see there's they're darkening on those. So part of the retrofit, if they say, well, we want to keep these housings, is going to be changing out the sockets. They're probably going to need to do a pretty significant retrofit if they're planning to keep the fixtures. I see stuff inside that metal ballast cover there. We don't know what that is. It could be something dripping out of the ballast. It could be something dripping from maybe water intrusion into the fixture, which would be a bad sign. Is it rust? Is it did the last guy change the lamp, spill his coffee in there? I doubt, but you never know. So you want to look at the age. Plus, they might say, well, we want to save them, to save some money, but the fixtures are 40 years old. It's like, well, probably not. Those fixtures were paid for long ago. And you want to look at the types of ballasts, the existing ballasts. So one thing that you need to note, we're seeing less and less of this, fortunately, is PCBs in the ballast. That's a toxin. So those would, if the ballast doesn't say has no PCBs, then it has to be assumed that there are PCBs, and you have to treat all those ballasts like hazardous waste, which just means more cost, different kind of handling. So modern fluorescent ballasts, since recent time, I can't remember the exact year, unfortunately, would say on them contains no PCBs. I have seen some newer electronic ballasts in the last 10 or 15 years that don't say that, because they're electronic and sort of by definition that they wouldn't have the PCBs. But the magnetic ballasts, even for modern T8 lamps, have to say that. And then you also want to look at the 277 volt, the one in the lower left. Usually they'll say that fairly prominently, and that'll give, sometimes customers aren't sure if they have 110 voltage or 277, and that'll make a difference, particularly when you're ordering components and fixtures. Unfortunately, you can't just look up in one fixture. So here's a project that we looked at a number of years ago, and this was in one room. We saw 2 lamp, and I won't get into what all of these mean because that's for another class, but just suffice it to say that even within one fixture, we saw a 2-lamp normal ballast factor, 2-lamp low ballast factor. We saw 3-lamp normal ballast factor, and these were 2-lamp fixtures, but it just seems like whoever did a retrofit in there just put whatever they had in their truck in the fixtures. We saw a fixture would have a battery backup, and we even saw some 277 volt, not in that same space, but in the same building. So you just have to look. Sometimes the drawings will help with that, but then you need to actually open up a few fixtures. And I think you have to decide, if you start seeing a whole range of things, then you just have to assume that you don't know anything, and you can't go based on just one or two fixtures. Document existing lighting controls. What kinds of controls do they have? Are they just on-off switches, which, nothing necessarily wrong with that, except that you probably want to do something better if you're doing a retrofit. And in fact, in many cases, as part of the retrofit, you'll have to meet modern code control standards, but not in every case, though. And that's maybe for a slightly separate class, but it has to do with how you're changing if you're changing the wiring, and if you're going back to the panel with your changes. If you're just changing out fixtures or changing out retrofitting the fixtures and leaving them in place, then you won't need to necessarily, although change meet the control standards, but it doesn't hurt to do that as part of the project. It could be that they're using manual dimmers. They could have occupancy sensors, but they may be old and failing, or otherwise modified in some way. We see people put spray paint on them, or they've done a variety of different things to defeat the sensor. Daylight sensors, same thing. There could be time clocks, old mechanical time clocks. Code doesn't allow those anymore, and you would use electronic multi-day time clocks. And then, of course, sometimes we still see breakers being used as the control for certain types of spaces, and that's no longer, that would be considered no controls, and that's no longer code either. With daylighting, it may be that you're not required to do a daylighting controls, but sometimes it's so easy. Like here's a case where you could even just put this on a timer, where this little pedestrian causeway here, anytime after 9 o'clock, even 8 o'clock, there's going to be plenty of light. And yet here it is daytime, and the lights are on. Maddeningly, this was the same facility. If you look at the picture on the right, the picture in the center takes you to the picture on the right, where you go into that dark enclosed space, and the lights aren't on in there. Being a lighting person for so long, I'm always looking at lighting, and it's sort of a curse. You see it everywhere. Anyway, but it also makes it kind of fun. All right, so we're still in documenting the existing conditions, walking around. We're looking at the room surfaces and thinking, what? This is interior design. I'm here to retrofit the lighting. But I'll show you that it can make a big difference. And the room surfaces can do a lot in terms of, how they affect not only the measured light levels, but the perceived light levels. And in fact, let's just go, if we can go up here. Yeah, so, as an example, this little interior hallway that we see on the right-hand side, it has all that sort of tan color. And we can see that the ceiling in there that carries through is white. So you see how dark those walls are. And it would be a lot brighter if we did some mitigation, or even with paint. So let's take a look. So here's a little model I did a number of years ago of a little office building. And if you look at it, you can tell that the upper section looks brighter than the lower section. So two things are going on. One, it looks brighter, but also actually is brighter. We can measure it. It's the same lighting, same furniture in both of those areas, just different surface reflectances. So yeah, so and I'm going to try and go through this quickly here in the interest of time, but if you're running a calculation, and this is true even if you're not doing a calculation, but this proves it kind of. So if you do a calculation of a space, a lighting calculation, you have to tell the computer program things about the space, like how big is it, how high is the ceiling, how big is the floor area, what kinds of fixtures are we putting in, how many, what's the spacing, where are the fixtures located, but you also have to put in room reflectances. And the default room reflectances, as you can see in a little chart in the lower section in the middle there, where it says surface reflectances, the default is 70% for the ceiling, 50% for the walls, and 20% for the floor. And that would just be your sort of default reflectances. If you didn't know anything else, that's what the program usually defaults. And so then if I put in my fixtures and do all this stuff, and I run my calculation, I would get average foot candles in that space of 35 average foot candles. And we don't need to fixate on whether that's good or bad. That's just the number. That's the quantity of light. Additionally, if we go all the way to the end right-hand side of that chart, our max to min ratio, maximum to minimum ratio is 11:1. So it's about, let's just say 10:1 brightness. The darkest spot in the room to the brightest spot in the room is about 10:1. All right. So let's say that the client wants to do a stained concrete floor, or maybe it's dark carpeting. Maybe they want to do, they're the client who's taking out the ceiling and leaving just the plenum. And maybe they're not going to spray it black, let's say, because then it wouldn't be 35. So we're looking at that lower section. But let's just say they're going to, maybe it's wood. That's something we see a lot, is that decking, that wooden ceiling. That'd be about 35% reflective. And maybe the walls are brick, or maybe they just want to paint them in a fun sort of dark, saturated accent color, green or dark blue or whatever. So instead of 35-foot candles, for the same lighting, same space, I now get 23-foot candles. And if my client, let's say this was a normal office, the target light level should be around 35. So if I'm down to 23, it's probably below recommendations, and it might even be below what your client would want. It's certainly significantly less light. And then if I look all the way at the maximum ratio, it's 21:1. So that means now it's twice it's what it was for the default. It's, the dark areas seem really dark and the bright areas seem really bright. Well, let's say I wanted to do a high performance. Say my client's like, we really need to save energy. We want to suck all the lighting out of the energy, all the energy out of this room as possible. Well, one way to do that is with lighting. So if I had high reflectances in there, and that would just be maybe a high performance ceiling tile. I paint the walls, it doesn't have to be shocking white, but just a nice bright color. In this case, I've used yellow, but it could be, different. I use yellow in an accent wall, and the other walls are white. And then the floor, in this case, if we look at the right-hand rendering, is a bamboo material. So it has, looks like wood, but it's a bright surface. I get over 50-foot candles. All right, so if our target is 35, that means I could use less lighting. I could save the client on some fixtures, and if I look at my max to min ratio, it's 7:1, so it's more uniform lighting, less contrast. Anyway, so These are measurable values, and then the only change is the surfaces. And you're thinking, well, this is a lot of work, and who's doing dark surfaces? But if we look at this is a picture in a space, concrete, dark floor, dark wood floor, saturated colors. So it's not uncommon that you might find this condition. Admittedly, and again, so these are industrial facilities. This is just free light, right? So if we paint everything, go to the extra effort to paint surfaces, we get extra lighting, better uniformity, better productivity. It can be a whole range of kinds of spaces where we would do that. It's not just offices or industrial facilities, parking garages, all kinds of spaces could benefit from high reflectances. So how do we find out what the reflectances are? We'll kind of just breeze through this a little bit, but it can be done with a light meter on site. And this isn't going to give you the exact number, but basically you hold your light meter to the wall in a space that's relatively representative. You wouldn't want to hold it in a spot of sunlight that happens to be coming through, or in a dark corner, but someplace that's getting representative light level, and take your reading. And then you hold the light level, take your light meter, and you turn it around and go about a foot away out from the wall and take another light level reading. Then you just do a simple calculation, which we have here, and that tells you the percentage of reflectance or the percentage of absorption, as the case may be. And so you know what the reflectance is of those spaces. Additionally, you can find out if you go in that maintenance closet and you see that they have some paint that they have that's actually representative of what they've been using. You can often go to the manufacturer and it'll tell you the reflectance of those particular paints, or if they're planning to repaint everything anyway, you can find out. And it's kind of telling if you look at this little color swatch here, that the color the tan that's on the bottom there is only 50% reflective. So it's absorbing half the light that strikes that. But most people would look at that and say, oh yeah, that's kind of bright. That's going to be reflective, but it's not really. So you can't really go by what you see. Okay. So this isn't exactly a trick question, but it kind of is. So when's the best time to do an audit of exterior lighting? During the night or during the day? Of course, intuitively, we think, well, you got to go out at night. And in fact, you do. But you also have to look during the day. Because if I only went out at night, I'd see all the lighting. Oops. Oh, what's happening? There we go. I'd see all the lighting is lit. But if I go out during the day, I see something else. I see that the lights are on during the day. They're not supposed to be on. And I wouldn't know that unless I went out there. Another thing, if you look at the lens on the fixture, in the lower right, you go out at night, everything looks bright. You can't tell what's happening. But if you go out during the day, you can see that lens is very yellowed. We're probably losing, 40% of the light in that lens is never making it out of the fixture. So they could go to a lower wattage if they're happy with the light levels they currently have at night. So you've gone out there and they say, yeah, this is pretty good. We just want new fixtures. Well, you can say, okay, they're losing a lot of light out of that fixture. So we could, we don't need to use the current wattages as our guiding, as our guideline. Another thing you can tell during the day that's harder to tell at night is what's the condition of the fixtures as well. We kind of touched on that in the last slide, and this kind of gets where having a good camera or binoculars can help you. You can see if there's rust. They might say we don't want new lighting, but you have to look at that and say, it's possible you need a whole new tower infrastructure. And it wouldn't make sense to put brand new fixtures on a structure they're going to need to replace. In this case, it's not actually particularly rusted, but it could be, you could tell things about the fasteners over the structure itself. So some more advanced lighting analysis tools would be luminance meter. So your typical light meter tells you foot candles. That tells you how much light is striking a surface. And that's what the industry uses for the most part. We talk about foot candles, but you know, if you're getting feedback from the client or from others that there's too much brightness, too much glare, or maybe you've got a sport facility and there's complaints from the neighbors, or you've got a billboard or or a side of a building that seems too bright. You want to see how much light is coming off of that surface, and you would need a luminance meter for that. Data loggers, you know, people are like, oh yeah, we hardly ever go into that space. You put a data logger in there and you find out that they're all the time, or vice versa. They say, oh yeah, we use that all the time. We don't want controls in there. We're always in there. And it turns out they're almost never in there. A data logger will tell you those things. Spectrometer, we're becoming more interested in not just, and we'll touch on this later, not just the color of lights, but what's happening with the spectrum in that light. Flicker is back, especially with LEDs. It kind of went away with electronic fluorescent ballasts, but it's a concern with some types of LED sources. Thermal imager, you can see, especially with LEDs that are that are temperature sensitive, if they're getting failures, you can find out if there's issues with hotspots and thermal management in the fixtures. A UV meter is a concern more and more, and maybe a GoPro. So people are, you know, putting those on, maybe even just their helmet, and they sort of walk through the space, they talk as they go, they document everything. I can't tell you how many times I've gone into spaces and I take pictures of what I think I'll need, and then I go back and maybe want to do a model of the space, and it turns out, what is that happening in that corner, or what's the relationship between this stairway and this doorway, and I just didn't get the right picture. So having a GoPro might help you with some of those things. So how much light do we need? We touched on this earlier. You know, this is a moving target, and I love this picture because here we have the captains of industry back circa 1939, Nela Park, you know, and they're deciding very important things. A couple things I love about this picture. One, they've got 200 foot candles of light, and they love it, which is about almost 4 times what is recommended now. But they also have the windows pretty much, the blinds are shut for the most part, you know, and so the daylighting is becoming less and less of an issue. Why? Well, who needs daylight when you can generate 200 foot candles? But of course, there's a price for that. So, and that's energy consumption. This is from the mid-70s IS handbook. We can see 150 foot candles is for a general office space. If you look on the right-hand side there, and they're recommending 150 foot candles, 100 foot candles, 70 foot candles. Those are big numbers, depending on the different tasks. We go to the current IS handbook. Well, it's not current anymore. I think they've gone to a different system, but it's still fairly new or fairly recent. This is the 10th edition. And there we see, if we look at the line there, this is reading and writing on that orange, or the green band on the left. Black ink, 300, 400 if it's blue ink, 300, 400, but those are lux. So we're seeing the use of lux more. So you'll see foot candles a lot. That's a quantity of light. Lux is that's used primarily in the U.S. Lux is the international, sort of like metric and standard, if you will, metric and feet. The good news is that 30 foot candle, 300 30 foot candles is about 300 lux. It's about 10 to 1, or 400 lux is about 40 foot candles. If you're getting into a real careful calculation, you do have to, it's not exactly right, but that gives you a good way to kind of make a generalization there. And you can kind of see, depending on whether you're given foot candles or given lux, you can easily move back and forth. So how much light do I need? How much light will I get? So people always ask, well, how much light do I need? That's the first question. And then with a retrofit, well, how much will I get? And that's an equally complicated answer. Even for this fixture, so here's a high bay fixture. It's a pretty standard kind of configuration. And you might be putting these in certainly warehouses or industrial facilities, but we'd see these in maybe food courts or concourses of different kinds. All kinds of spaces potentially might have this type of fixture, maybe slightly different look to it. But I see all these, if I look to the right there, there's all these different configurations that fixture can come in. So I don't know how much light I'll get until I know which one I'm using. And here's a case where there's so many options. If I look in the upper section, so it's, this series is JCBL, okay. And then as I'm moving from left to right, I see how many lumens. I have all these different choices of lumen packages. Let's say I picked a 30,000 lumen. We want the big one. And then I can pick different reflectors. I can pick different lenses. I can pick voltages. That won't necessarily affect light level that much, although it does a little bit. In this case, it just comes dimming. That's good news. So I'm going to have 0 to 10 dimming. But then I can pick different colors. I can pick 3K to 3500, 40K, and then 5K. As they say. And then so different color temperatures, and then different color renderings, 70 CRI, 80 CRI, and 90 CRI. And you're like, well, let's pick the one that has the highest lumens. So if I look at the lower section, I've circled my little 30,000 lumen number. If I look at the two lumen, the two choices that are circled there, I get either 28,000 lumens or 19,000 lumens. Well, that's, pretty big difference for the same fixture. And what causes that difference? Well, in one case, I've picked a 4,000 Kelvin 70 CRI, and I get 125 lumens per watt. In the other case, I've picked a 3,000 Kelvin 90 CRI, and I'm only 80 lumens per watt. So you think, well, I'll just pick the one with the highest. But let's take a quick look here. I think maybe we have a little poll. We do have a little poll. I don't know. Katie, did we get this into the actual poll?
Yeah, let me put it up here. Excellent. And you can choose more than one, but probably you will just.
I think we just want to maybe choose one.
Yeah, all right. So click your expertise with CRI and CCT.
You can choose one, but don't pick the bottom one. Well, you can, I suppose.
All right, we're going to close this in about 5, 3. Last chance. Okay, close. And let me share these results. Looks like maybe go over CRI and CCT.
Excellent.
Yeah, about 43% shows could use a refresher, and then another 30% said they get them confused.
Yeah. Okay. Perfect. Great. Yeah, because I was going through pretty fast there. So we'll Let's do it. So light has, as we can see, a lot of different qualities of light. Both of these pictures are taken under sort of architectural type lighting, but it's pretty dramatically different. So what's going on? What's the difference? In fact, the cars are the same above and below. In the lower one, I can't tell what color those cars are at all. And of course, color discrimination is certainly one of the big tools of lighting. So, all right. So we use CCT, correlated color temperature, to describe the color of a light source. So if we look at that little band, my little chart there on the left, and the band, we can see we go from warm down there at the bottom all the way to fairly blue or cool at the top. Those are all light sources that we might find out in the real world, right? So some obviously candlelight, that's a thing that's been around for a while. High pressure sodium, incandescent light, halogen incandescent. Then we get into metal halide and ceramic metal halide and sunlight, right? Sunlight, heard of that? The real sunlight, at least at noon at the equator, is considered to be 5,000 kelvins, and in daylight is considered to be 6,500 kelvins. And if you're up on Mount Rainier on a cloudless day, it might be even bluer than that, or higher Kelvin. It's a little counterintuitive. The higher the Kelvin, the bluer the light. Let's see, I think I have that. No, I don't have that. So, and as far as LEDs go, so fluorescent can be a whole range, but they can usually only be one. LEDs can be almost any color temperature. And sometimes when we refer to color temperature, we might just say 35K or 3K or 27K, and that's the K is Kelvin. And sometimes we get a little fast and loose with this, abbreviate. It's not, so we probably should say 4,100 kelvins, but we might just say 41K. So I apologize if I'm being too nerdy. So that's color temperature. Color rendering is a different thing. That's how well a light source renders or reveals this true color of an object, and that might be a point of some discussion. But for this purpose, if we look at the upper box on the left-hand side, everything looks bright and vivid, and we have a high color rendering. It's 85. If we go to the one below it, everything looks a little dull, particularly those complexions on the faces. They look a little washed out and jaundiced. And then we have a sort of mediocre color rendering. So for the most part, the higher the color rendering, the better. But we don't always need the best color rendering, let's say, and we'll touch on that in just a second. So those are the two things there. Let's see what's on the door. And so in the real world, we can find there's a combination of things where we have high pressure sodium lighting. Remember, I talked about that hotel lobby, that high pressure sodium. That's a kind of color rendering of 22, very poor. Old style mercury vapor. Most of us, well, a lot of the older people have seen it, but a lot of young people, you hardly ever see it used anymore. Occasionally. And then we look at the one in the lower middle, and we can see we have a white light source that has high color rendering, and so we're getting true color representation. And that can be done with a range of quality light sources, but nowadays it's mostly all done with LEDs. And in this case, it's a CRI of 80, and that's quite acceptable for many applications. So let's look at that chart again. So the one that had the highest lumens, the 2800 lumen, the one that's sort of in the middle left, that's got a color temperature of 4,000 Kelvin, so it's going to be fairly cool to neutral, that would be fine for many applications. But we may not, it might be a little blue for some cases, like if say we had a food court, it could be fine, but it might not be. But where it might be a deal breaker is it's 70 CRI. So that would be sort of just in the good range. And so if I'm doing something with retail, maybe I have a mall concourse or an airport concourse, and I want it to feel vibrant and alive, and I want it to just feel good, probably not great. If I'm doing a warehouse, and really it's just a case of getting enough light and decent quality light so people can read the labels on the boxes and pick them easily, then it might be quite acceptable. The other one that's circled is 3000 kelvins, and it's 90 CRI. And you're thinking, well, shoot, so that's warmer, higher color rendering. And you think, why don't I just use that everywhere? Well, there's a little bit of a penalty. I get less light. The lumens, I look at the little chart I have on the lower right, we go from 125 lumens per watt to 80 lumens per watt. Now, sometimes that's just the price to pay. If you want high quality, if you need high quality, like in a retail space, then that's just reality. You can't, you don't want lower. It might be the difference between, say, a Target and a Home Depot kind of thing, or an IKEA or a Home Depot. One might, the one may be acceptable for one, but not the other. Okay. And so photometric files are what we use to do calculations. I just think this is amusing. That one fixture has all these possible combinations of lenses, color temperature, color rendering that are going to give you different outcomes. So when people say, which one should I choose? I'm saying, well, I don't know. Do you want to pay me to run through all these possibilities? Usually not. Okay. Okay, another quick pop quiz. And I'm going to need to pick up the pace.
Pop quiz. All right. I'm just going to give everybody 20 seconds.
Yes.
What are the benefits of having light colored interior surfaces? You can select more than one. All right. 3, 2, 1. Closed. All right. And everybody got it improves visual comfort.
Yeah.
Most people chose potential higher light levels and a potential to save energy. And about 36% chose lower contrast ratios. Now, somebody did like your joke about it being interior design, and they chose that.
Yes. Well, yeah. I mean, the thing of it is, though, you have to, if you're coming in as to help do a lighting retrofit, you can't just silo yourself. If you see them picking, dark colors, or you even have to ask. Now, maybe you're not going to dig your heels and say, well, you can't do that, but you have to say, okay, you have very aggressive energy saving goals, but you're picking dark colors. It's going to make it harder to achieve those goals. And then maybe just leave it at that. All right, common retrofit applications. So we've got recessed cans, we've got recessed troughers, we've got surface mount fixtures, high bay fixtures, and exterior fixtures. So T-LEDs, those are, we could spend a whole class on these, and they're basically look like fluorescent tubes that are LED, and they, in theory, you would just take out your fluorescent tube and put in this magical T-LED, and everybody would be happy. And then occasionally it happens that way. You do have to look at the light distribution, though, and we talked about this earlier. So a fluorescent tube, if you look on the right-hand side, is omnidirectional. And most of these T-LEDs, even the ones that look to be omnidirectional, when you're holding them actually do have a certain degree of directionality. And that's not always a bad thing, depending on the type of fixture and your client's level of comfort with odd appearances. You know, with a recessed troffer style fixture, you're trying to drive light down out of the fixture, so it could work. But if you have an indirect pendant, where if we look at the picture on the photograph, we want some light to go up and some light to go down. And if I have a retrofit that's only goes one way, I have to choose which one I'm doing, and usually something's going to suffer if you do that. There's also different types of wiring for TLEDs, and in the interest of time, I'm not going to go through too much of this, except to say that some claim to not require any wiring. They use the existing ballasts. But if you remember the slide we had earlier about the room where we opened up a couple of fixtures and found a whole range of ballasts, typically these are work on only certain types of ballasts. And if I don't know what the ballasts are in a space, and I'm putting dozens, hundreds of these in a floor plate, its chances are I'm going to have some problems. Then there's ones where you rewire, you disconnect the ballast. That's this middle one, the UL type B. You know, and that has its own fraught concerns. Now you have to have someone actually get up there and rewire the fixture, which may not be part of the scope if your idea was you were just going to change the light bulbs. Now we have to have rewiring, and maybe there's UL issues or safety issues. And then there's ones where you have a remote driver. So with LEDs, instead of a ballast, it's a little device that looks a lot like the ballast that makes the LEDs work, and we call it a driver, a little power supply. And some of those, with the first two choices, the driver is built into the tube. With the third choice, the lower one, the driver is separate from the tube, and it needs to be mounted somewhere inside the fixture housing. We call it UL type C. And sometimes when does a tube replacement become actually a kit? And this is relevant with certain utilities. So the ballast compatible ones, just to kind of run through this particular one, you can maybe read this later, but ballast compatible with 90% of electronic ballasts. Well, that means 10% aren't going to, it won't be compatible with. And then this manufacturer says in their fine print, due to numerous ballast designs and topologies, this lamp should be tested on existing ballasts before mass quantities are installed. Well, that's a good plan, but we don't always know what the ballasts are, as we've seen. And this is not intended for use with older dedicated wattage instant start ballasts. Well, generally, if you're doing a retrofit, you have older equipment. So yeah, not a good plan there. The ones where you rewire eliminates the concerns of ballast compatibility, but, and here's a quote from the manufacturer, most include integral, this is actually from a US DOE report, most include an integral driver. In addition, the LED lamps may require power to be disconnected at one or both ends. Yeah, so the wiring is often different from product to product, so you're never sure. Further, each lamp type may require either a shunted or unshunted lamp holders. I think we'll touch on that in this one. So we talked about replacing the sockets, but you need to know which ones you're going to get. And particularly if you weren't planning to replace the sockets, this is relevant. And it says right here, this is from one manufacturer who's selling this product, do not use this retrofit kit in luminaires employing shunted bipin lamp holders. Okay, they're telling us not to do that if it's shunted. The note is here, shunted lamp holders are found only in the luminaires with instant start ballasts. Well, guess what? 90% of the fixtures, fluorescent fixtures out there our instant start. That's by far the most popular choice. So trouble on the horizon. Here's cases where they sell a sort of a combination. It's not quite a kit, but they sell you the tubes and the appropriate driver, which are included. So that at least you know there's going to be compatibility there. And here's a case where we have remote driver tubes. And the lamps, this is a kind of funny one. The lamps, if you look at the very left-hand side of the tube, it has the little pins, and they actually are held in place by the lamp holders, the tombstones on the fixture, the sockets, but there's no power going to those. It's just mechanically holding them in place, and the tube is being powered through that little low-voltage wire with the quick connect. The only problem there is UL, I think it's UL, says that if the product touches the sockets, it's considered a lamp. So yeah, it could cause problems. Plus, sometimes the lamp holders are failing and are not really holding things well. So then we have kits. Here's what we call a basic kit. This is from Cree, who apparently is may no longer be in business. Not really sure what their status is. So I'll withdraw that last statement. But here's a kit where you have a driver, and then you have some things that look like tubes, and they would go into place. They would be held in with X screws to the fixture. The thing about something like this is you don't really get new optics. If your optics are in good shape and everybody likes what's happening optically, this may be fine. Then there's kits that are what we call sort of complete kits, where you get new optics. It looks like a new fixture. They come kind of in two flavors. Sometimes if you look at the one on the left, you're basically building a new fixture. There's dozens of little parts you have to assemble and put together and screw in place and snap together. Others, you basically just take out everything from the existing fixture except the housing and the power drop. There's a little, black and the white wire and the ground wire. And then you hook up this complete kit, you pop it in place, and now it looks like you have a brand new fixture. And you almost do have a new fixture. They cost almost as much as a new fixture, but there might be reasons why you don't want to replace the whole fixture. And these are always times when it's good to ask, is it appropriate to actually replace the fixtures? Here we have this sort of 70s/80s workspace. If they're doing a big old remodel, new furniture, new carpet, painting, new ceiling tiles, everything, you don't want the same old fixtures. You probably want new lighting too. All right, here's a quickie on lumens and how we can't just look at lumens. Lumens are not always lumens, let's just say it. So here we've got a compact fluorescent fixture on the left, CFL, and it has four 1800 lumen lamps for, let's say, about 7,200 lumens, lamp lumens. We'll just call them lamp lumens. And now we have a fixture, possible retrofit, and that's got only 2,500 lumens. And then the one on the right has only 1,800, we'll say maybe 1,900 lumens. We're thinking, geez, neither one of these is going to do the job. But we'll find out that that's not always the case. So every type of fixture has a certain efficiency. There's the amount of light that the light source puts out, and then there's the amount of light that actually exits the fixture and goes into the space. And so in the old days, that would be the luminaire efficiency. And so with our fluorescent fixture, we had an efficiency of 37%. That means over 60% of the light never makes it out of that fixture. So of our 7,200 lumens, we're only really getting about 2,600. Yeah, it's shocking. Now we look at the fixture A, our LED fixture, and they claim that they're giving out 2,800 lumens, or where was it? Somewhere in there they mentioned it, but they call that source lumens. What that tells us, oh yeah, there it is, underlined 2,500 lumens. And those are source lumens. What that tells us is they haven't actually done a photometric analysis of that fixture. They've just taken their LEDs, and those LEDs give out 2,500 lumens, and they stuck them inside a fixture. So but if we look at the fixture B, the LED fixture, that was delivered lumens. And so again, we had about 1,900, 1,890 lumens, 1,900. So that's less, but if we compare them, that's the actual amount of light we get. Those are delivered lumens. So one thing that we can use, if the manufacturer has a thing called the lighting facts label, they have to declare the luminaire lumens. Other times in their literature, it will say delivered lumens. If they don't say that, we need to be cautious, and it could be that we're going to be losing 60% of those source lumens in the fixture. Most of the more reputable manufacturers, or ones who are doing products appropriate for commercial applications, will have delivered lumens. Also, you need to know if you're doing a screw-in type retrofit, are we putting in an omnidirectional lamp, or are we putting in a directional lamp? And again, that's a case where we've got a directional lamp on the left that's a spotlight that's 75 lumens per watt, and the one on the right is 95 lumens per watt. But depending on the kind of fixture I'm putting it in, I may not be getting most of those lumens. So with directional lamps, we have things we need to look at. One is beam angle and center beam candle power. Those are the two things that we'll often see. We don't usually see field angle mentioned, but it is relevant when we think about things like glare and visual comfort. So omnidirectional lamps put out light in all directions, and if we put them inside of, say, a recessed can, so if we look at our little chart diagram at the bottom, we see our 65 lumens per watt from our compact fluorescent. This would be maybe similar, whether we're using a metal halide or a regular incandescent. Most recessed fixtures, they're on a good day, they have an efficiency, this would be recessed cans, have an efficiency of about 50%. So we're going to lose about half of that light. So our 65 lumens per watt might go down to 35 lumens per watt. Again, here we can see I'm always creeping around in the plenums. And so here's a compact fluorescent fixture. If I go up and look in that ceiling tile, look up in the plenum, look at all that light. I can see up there. I can actually take a picture of the label of that with no flash, no extra light, just from the ambient light. Guess where that light's coming from? The recessed fixtures. All that light's not making it into the space. So sometimes if we take out a omnidirectional source like the compact fluorescent on the left and replace it with an LED that's directional, I can cut my power consumption considerably, and my lumens might be lower, but I'm actually getting more light into the space. But we do need to be careful with some of these so-called compact fluorescent retrofits and check the compatibility. And I'll just run through this here a few. I would say most of these are going to not pencil out. But here's one where their literature said simply plug in the replacement lamp into the existing ballast. Okay, well, I checked my existing ballast just to make sure it was compatible, and I went into their guide and I looked up the ballast, and sure enough, that was the one I had in my fixture, and I had I didn't have any red flags there, so I was like, great, this is going to work. But guess what? It didn't work. And then if I looked in their fine print, they had an important notice that over the years, some of these ballasts undergo changes, so performing an on-site test before installation is recommended. Okay, so thanks for letting me know that. Here's one I thought was particularly clever. So this company in their large print says compatible with most fluorescent ballasts. Okay, most. I'm feeling lucky. But if I look down at the little asterisk, what's that mean? Oh, it says for maintenance and energy savings reasons, this company recommends bypassing all ballasts for permanent operation. Usually when you're doing a retrofit, it's not temporary. You are doing this, it's a permanent operation. So I don't know what they mean by that. But basically they're saying, yeah, you better bypass the ballasts. And that's a lot of work for not a lot of wattage. So we're looking at retrofit kits. Again, in this case, a lot of these retrofit kits take a fixture that looks a little like this and turn it into one that looks like the one on the right. You know, it goes from one that has no lens to one that does have a lens. That might be fine. But there are more commercial type retrofit kits where you're actually putting in something that is truly recessed. You don't have that lens right there. And that might be better, especially for commercial applications where you're maybe concerned about glare, or you really need a higher lumen level. Ellie, for exterior, you know, it's interesting. This is a little factoid. Mogul-based HID lamps are used in only 2%. Mogul's bases are those big bases that we see on the large high-intensity discharge lamps. Use only 2% of lamp sockets in the US, but they used 26% of the lighting energy in the United States and are second only to linear fluorescent lamps for lighting consumption. So there's not a lot of them out there, but they generally use a lot of power. They use, you know, 400 watts is a low wattage for exterior, and usually they're 1,000 watt. So you know, it's a big target if you're looking to do retrofits. One of the things to keep in mind though is so when you're up on these are up at 40-foot masts, right? So that's a large area, long distance to cover, and the way to do that is with good optics. And the way you get good optics is with a point source. We'll just suffice to say that that's what's generally needed when you're trying to throw light 80 feet to the side and have it actually deliver. So with LEDs, as with other types of lighting sources, to get more lumens, usually you have to make it bigger, physically bigger. And so here's our little 700 lumen, 760 lumen small fixed thing. If I want high lumens, in this case 7,000 lumens, I need to make it bigger. And you can see it's physically large. And what happens there? So will it act as a point source? Different HID optical systems. So in some systems, we want the light source is horizontally mounted. Other times it's vertically mounted, and that is going to have some bearing on how the light's going to be distributed and the form factor of the retrofit. Reflector types also. So we've got translucent reflectors. Sometimes they are optical prisms. Other times they're just sort of textured surfaces. It's good to know which one you have. And then we have solid aluminum, usually reflectors that don't allow any light to pass through. And that may, depending on your the form factor of your fixture, and it may, one type of retrofit may or may not be acceptable. So if what I had was an appearance on the right, on the left rather, and my retrofit gave me an appearance on the left, on the right, you can see how it's shadowy up there at the top. So that might not be acceptable. It might be perfectly fine for some applications, might not be for others. I know certain retailers are very picky about how the fixtures look, and others maybe less so. Here's a case. Some of you might recognize this as the Seattle, what used to be called the bus tunnel, what I think is soon going to be our train tunnel. Well, it is the train tunnel, and I think they're retrofitting it to go off to Bellevue. Anyway, I digress. If we look at the decorative fixtures on the right, that big luminous thing, you can see the whole thing glows. It's got a lower portion that shoots light down, and then that upper portion radiates light out to the sides and looks decorative. And they retrofitted that with LEDs. They did the same to those little canopy mounted, the surface mounted ones that are shorter, only they couldn't get any, I guess they didn't they don't glow to the sides, they just send light out the bottom. So there's a case where that might not have been acceptable in some cases. I mean, they went with it, it looks like. It's sometimes it's good to not be surprised. All right, here's a little case study. Run through this one where the client was doing a retrofit in a large industrial space, and they were planning to do a retrofit a certain way, and they asked us what we thought of their concept. And you can see from this drawing down here, this rendering, I did a little model. You can see that high racking, and there's a tiny little person standing there. This is a big space with a lot of fixtures. And so their plan was to just do well, what I had to start out with was try to model their existing condition. And they had mercury vapor lighting, which is pretty terrible. So almost anything you do will be an improvement. And they had 30-foot candles average, and their power density was, where are we here? Lighting power density was 2 watts per square foot, pretty high for that kind of space. So their retrofit, and they had 30-foot candles. So the retrofit was going to give them 35-foot candles, and it was going to be basically 0.69. If we look in the lower right, you can see the lighting power density is 0.697, basically 0.7 watts per square foot. So, they increased the light level a little bit, and lowered the power density considerably. So pop the champagne corks, we're done. But we weren't sure if this was going to actually be the best solution for them. And at the time, if you look at the fixture choice, you can see it there in the lower left. It was a screw-in, but to make that work, you actually had to get up there and rewire the fixture. So to get somebody over 70 feet up in the air to fiddle around with those fixtures. Plus, those things at that time cost about $300. So this wasn't just a little $49, let's see if it works kind of thing. So we thought, well, what if they actually put in a real fixture? Since they have to get up there anyway, cut down the old ones, put in a new one, put in a new fixture, and see what happens. So here's a pretty good high bay fixture, and they got 80-foot candles. They went from 30-foot candles to 80. The power was 0.99, basically 1 watt per square foot. So they cut the wattage in half from where they were, but the light levels were off the chart. So what could we do? Well, what if we lowered, they had a lot of fixtures, fairly high fixture density. So what if we lowered the quantity of fixtures. So we put in about half the fixtures and carefully arranged them so they weren't getting dark. They still had good uniformity. They were buying a fixture, so they went from a $300 retrofit screw-in to probably a $500 high bay actual fixture, but they only bought half of the fixtures. And they were at 0.5 watts per square foot, which was less than they were going to be before. And they were 42-foot candles, so it was plenty bright. They could have possibly maybe gone with a slightly lower output fixture. But anyway, it just goes to show if you push a little bit, you can actually get maybe some better results. Here's a little pop quiz, and I think maybe what we'll do, Katie, in the interest of time, is I'm going to read through this one so we can all kind of share. So before doing an LED lamp only retrofit, always check to see which of the following. One is that the fixture is in good shape. Two, that the lamp is compatible with the electronics, ballasts, and existing controls, that the optics are appropriate, that the utility is agreeable, right? So not all utilities are, and I didn't mention this earlier, but you need to reach out to utility early on so that you can make sure that your method is going to be something if a rebate is what you're interested in. And two, that the customer has enough money. Of course, you probably want to do that first. Anyway, but those are good things to check. So here's a little bonus, and I think we can get this done in 10 minutes. Wanted to touch on luminaire level lighting controls, LLC, and network lighting controls, and some of the benefits that you get from that. Why use controls at all? Save energy and save on maintenance costs, right? I mean, we don't want people to leave the building and the lights stay burning on all night. So, I mean, I think intuitively know that. Although we have seen this over the years in some spaces. So, which controls and how? Well, I mean, so on off. I mean, that's one choice. But in some ways, it shouldn't be all or nothing. That's a kind of a blunt instrument, we'll just say. So we have occupancy sensors. That's another way to do it. We'll do it when people aren't there. We'll do something. But, I don't want to devalue this with the worth of this guy. But here we have this whole space lit with just one person in there. Here's the other extreme, right, where we have a big old space, one person's in there and there's one little pool of light. That may not be the best outcome either for a variety of reasons. So we get into modern lighting controls, and we've become kind of accustomed to the lights changing and the tasks changing. The lights changing based on, we maybe want to change the intensity. We want to change it based on occupancy. We want to change it based on what's happening with the daylight, personal preference, or different types of tasks. So these would be reasons we might want to change the lighting. So what kind of controls do these things? Well, we have, as I mentioned earlier, on-off switches, and that could work in some kinds of spaces. Manual dimmers, so we want to change the intensity, and sometimes we're giving users control in real time of the lights in their general work area. Occupancy sensors, vacancy, we'll touch on that, daylight sensors, and time clocks based on time of day or the calendar. We could spend a little more time on this, but I'm just going to say that how you set the sensor can have a big impact on the success or failure of a particular control device. And we've seen some sensors that are like, wow, it's so easy, just one button. But you're pressing this little button. In this case, to get to a certain setting, I'm gonna have to press that button 9 times and then count 9 little blinks back. And then if I want to do a separate type of setting, I have to press it maybe 7 times and then press it 4 times and count 4 codes that come back, and it's crazy. And you're trying to do this while, so you've got the technicians in there trying to do that while the carpet guys are in there, or the punch list is going on. The painters are maybe just finishing up. So it's a busy commercial space. So, yeah. Here's another case where self-programming, one button setup. I'll be honest, I've seen this setup done a couple of different times. I think if you do it a lot, it makes sense. Or if everything goes according to plan, it is sort of just one setting, one push, and it all sort of works. But that hasn't been my experience. So we're seeing graphical user interfaces that are a little more intuitive. They tend to cost more. So sometimes you have to purchase something that mounts to the wall, or a separate little GUI. But a lot of times these can be downloaded onto a phone that you might already have. And that can be a way to save on some costs. And so that's something that we're seeing. So why use controls? Well, one reason we use controls is because we have to. Energy codes mandate certain types of controls, and daylighting controls are one that are often required. So let's look at, here's a floor plate, and I think that we can look at this space and we can see we're used to daylighting controls, but guess what? We're not. So here's our perimeter wall, and we have our daylight zone. But now we also have primary and secondary daylight zones. So it gets a little more complicated. Another reason we use controls is based on occupancy, and we're used to that too. Here's lunchroom, conference rooms, private offices, where we're used to putting controls in. But now we're also putting in controls in open office areas. You can see these open offices are now controlled. Basically, almost every space needs some sort of occupancy control. And then we also have maybe controls based on egress. And so when we layer all that together, we have a fairly complex zoning pattern. And so, that's not impossible, but it does get complicated. So here's a case where, I walk by a big empty room and the lights are on, and we know that's not good. I walk by a big empty room and there's lots of daylight, and the lights are off, and that's pretty good. But what happens when the room's occupied? And here's a space where we have lots of daylight, the room's occupied, and the lights are off, and this is a success. So exemptions to controls. Controls are mandatory unless we're using so-called LLLC types of products. And those are luminaire level lighting controls, and that's where the occupancy and the daylighting is baked right into the fixture. Each fixture has its own controls. That could never happen. Well, we're used to putting individual controls on street lights or parking lot lights. I mean, so it's not impossible. What about and we actually have started doing it in interior spaces. In the past, we couldn't really do it with high bay fixtures, but as we've gotten into fluorescent and even better with LED, we can turn the lights on and off without too much trouble. But and I would say commercial, big warehouse, industrial spaces, and warehouse spaces, you have high wattage fixtures in a relatively low density. So controls, you get a lot of bang for your buck. You go into an office and you have a lot of fixtures and they're not high wattage. So it's a higher fixture density per square foot. So it's been a little harder to make, but there's been a convergence of technologies and timing here. So we have miniaturization of control devices. We have controllable light sources like LEDs that are very controllable. We have higher bandwidth, so we can have network controls that are it's easier to do. We don't get bogged down. We can do floor after floor of these without overloading our servers. Plus, we're having more stringent requirements for controls. The advantages, more savings due to higher energy, higher granularity with LLC. Each fixture has its own controls. No rewiring needed due to wireless functionality and ability to rezone if the area changes. Why do we put all this stuff on lighting? Well, lighting is a handy spot. It's in places where everybody is. It's also can see the entire space. Usually lighting it's a good location to have a network. Just want to show you this little scenario here. We're almost done where we have LLC in a space. So let's say here's our floor plate and it's nighttime. And we have in the yellow is just maybe some egress lighting that's just cruising along at about 10% in the core of this space. And we get somebody who arrives early. It's still dark out. Maybe it's, maybe the guy's there at 6 a.m. or something. So the ambient light, all the fixtures in the space, it says, oh, somebody's here. The light's up to 30%. But in the traffic pattern where we see the red arrows, those go up to 90%. Now the person goes to their workstation and they're working away. And then another person arrives. But now it's sort of, it's daylight. And we can see that our daylighting zone, if we look at the perimeter, we have that blue line there, and the daylighting zone is constricted a little bit. And so the ambient area is now just that yellow line, and that's at 30%. The two people that are there, their workstations are still at 90% because they're really not in the daylighting zones. And then later on, as the day progresses, we get people showing up, these people in the conference room, those areas are all controlled, but the general space is either off or at 30%, and we just have the 90% in some of those other areas. So we can see a high degree of granularity. And it doesn't all have to be Troffer type fixtures. We can see LLC on pendants. I like this picture because we can see in the middle, that middle fixture, that fixture's off, nobody's there. We can see other areas where people are there and the lights are on. So good things are happening. I think I'm gonna take this little quiz for you. I apologize, we've gone a little over, and but the most efficient, the most effective retrofit luminaire is one that's energy efficient, has the appropriate color qualities, puts light where it's needed, has low operating costs, and is controllable. Again, reach out to your utilities if you're going to do a retrofit early and often. Here's Seattle City Lights 800 number for their energy advisors. We've included Puget Sound Energy's contact information here. We also have Snohomish County PUD, Tacoma Power. All of their contact informations are here. If you're working outside those areas or you just want to go to our website, I encourage it. And we've, under our resources, have all the utilities, BC Hydro, Pacific Power, you name it. So thank you very much. And again, apologize if we went a little over time. I'm turning it over to Katie if she's still here.
Nah, I left. Yes, just really quick, thank you everyone for joining us. A lot of information to go through. Thank you, Eric. That was great. If you want to go to the next slide, I think it just says, yeah. Oh, we didn't take that. That's an old slide.
I thought we did.
We took it out. It didn't show up as taken out. Anyway, our next webinar is in August. Watch online or in the newsletter. There's Eric's information, and again, our email address if you think of anything that you didn't think of today. And the next slide might just be reminder that we're powered by Seattle City Light. And that is it. If you have AIA credits you want to get, make sure to take the survey, put your number or whatever it is for AIA, I don't remember, so that we can add that to get you those learning units. All right, thank you everybody. We will see you next time.
Thanks folks, appreciate it.